This conference will now be recorded.
Very good evening, students. We were solving the NEET UG 2023 physics paper. So we are continuing that. We have selected some 10 questions today to solve in this session. So let us try to solve these questions. Excuse me. So the first question says, the half-life of a radioactive substance is 20 minutes. That means T half is 20 minutes. In how much time the activity of the substance drops to this 1/16th of its initial value. Let us say initial value of the activity is A0. Okay, so at any time the activity, suppose the time it takes to drop the activity to 1/16th of its initial value is some t. So how do we write that? We write activity at any time t will be A0 initial e to the power minus lambda t. So this is the formula similar to that of the number, and in fact number or this number into lambda is actually activity. Anyway, so here A has become, at that particular time, this has become 1/16th of initial value of the activity. That means I can write here A0 by 16. So this is as it is. So now this becomes like this, and e to the power lambda t will be equal to 16. Now if we take ln to come out of exponential, so this will be ln 16, so which I can actually write as ln 2 to the power 4, and this 4 will be coming in front. So we have got the time t is equal to 4 ln 2 by lambda. Now t half is given, and what is the relation between t half and lambda is, say ln 2 by lambda is t half. So this value of lambda we can replace as ln 2 by 20 minutes. Okay, with this if we reply, look how it goes. It goes like this: 4 ln 2 divided by lambda is equal to ln 2 divided by 20. So 20 will come here, and this whole thing will be in minute. So see, this ln 2 cancels each other, so it will be 80 minutes. Okay, this is the answer. So 80 minutes is the answer for this question, and option C will be correct here. Now go to the next question. So this question is very interesting. The question says the temperature of a gas is this. Let us say T1 is minus 50 degrees centigrade. To what temperature the gas be heated so that the RMS speed increases by 3 times? Increases by 3 times means the initial value plus 3 T1. Okay, I'm sorry, this is V. Velocity has increased, so you have to find out the T2 at which the V1, if the RMS speed was 1 when the temperature is minus 50 degrees centigrade, then V2 will be equal to V1 plus 3 of V1. Okay, that means 4 of V1. V2 is equal to. Okay, with this we'll just go ahead. See, RMS speed is anyway, it is how it is. It is actually proportional to, see, RMS speed, any speed, RMS speed or maximum probable speed or average speed, anything, see, they are directly proportional to T, and this T is in Kelvin, is in Kelvin. Now look, if I write RMS1, that means when the temperature was this, so minus, say this is 273 minus of 50, so how much you get? 2 to 3. Okay, so this is directly proportional to 2 to 3 Kelvin, right? And similarly, VRMS 2 will be directly proportional to the temperature we need to find out, that is in Kelvin. Okay, now see what are the informations given. See, it is given that if the RMS speed at T is equal to minus 50 degree is V1, then V2 will be, see, let us say this is V1 as well, and this is V2, sorry, V2 here. So V1, we have to find out the temperature. So let us say VRMS 2 divided by VRMS 1. This is equal to VRMS directly proportional to T, so T2 in Kelvin, and divided by VR1. This is T1. Okay, T1. Now in this case, see, if this was V, if this was, sorry, this will be 4V if this was V. Okay, that means this ratio is 4, as I have shown you in the beginning itself, this one. This is square root of T2 by T1. Now if we write here, this is 4 root T1. Okay, so T2 by T1, root T2 by T1. So T2 is equal to this. Okay, what is T2 then? T2 will, let us take square of both sides. Okay, square of both sides means this is T1 again. So T1 is 2, 2, 3 into 16. So this will be in Kelvin. Okay. So this is the T2 we have got. Now we have to find out what is in degree centigrade. So this is in Kelvin. Degree centigrade, we need to just subtract that 2 to 3. So this is, oh, I'm sorry, this is 273. We have to subtract 273. 273 we have to subtract to make it to degree centigrade. Five. Oh, this is 9. 9 3, so it is 2. So this will be 295 Kelvin. So this will be T2. T2 is actually, so this much is the temperature to which we have to heat it up. Okay, we have to heat the gas up to this temperature, 3205 95 95 Kelvin. Oh, I'm sorry, this is not Kelvin, this is degree centigrade. Finally, this is degree centigrade. Let us move on to the next problem. Okay, here the option I need to show. So this option is the correct answer here. Okay. Now, let us go to the third question. So this question is related to Carnot engine. So what does this say? Let us see. A Carnot engine has an efficiency 50%. First of all, efficiency of a Carnot engine is given by eta is equal to 1 minus Q2, that is the heat absorbed, and this Q1 is heat released, and it has a proportional relation of temperature as well. So 1 minus T2 by Q1. Okay, now the question is, when the source is at a temperature C, source is at temperature 327, the temperature of the sinks. So there are two regions, you know, that sink and source. If the source temperature is given is this, let us write in terms of Kelvin. Sorry, this is 600. 500. So this is 600. So 600 by T1. T1 is the source temperature and sink temperature is T2. So what is given is the source temperature is given. So this is temperature of source, sink, sink. T1 is temperature of source. Okay. So let us put it here. Eta is equal to so this is 50%. I can write 50 by 100 or 5 we can write T1 minus T2 here 1 minus T2 T2 let us keep that as it is. T1 is how much? T1 is 500 degrees centigrade. Okay, now if we solve this problem, then slowly we'll be able to get the answer. So I think this is 600, right? So this is 600, not 500. This is 600. Okay, so here let us do a little bit of simplification. So this is 50 by 100. That means left hand side is half, and this is 1 minus T2 by T1. 1 minus T2 by 600. So T2 by 600. This is minus half actually, minus plus half only. Okay, so now we can do it. This is as 600 by 2. So this is actually in Kelvin. We have to make it in degree centigrade. So this is actually 300 Kelvin. So the Carnot engine has to be operated in degree centigrade, 27 degrees centigrade. Okay, 27 degrees centigrade is the temperature of the sink. This is the answer. Okay, so 27 this is Kelvin, this is degree centigrade. Now we'll go to the next problem. This problem is from magnetostatics. So what is this problem saying? The magnetic energy stored in inductor of 4 microfarad and 1 ampere. So how to solve this problem? The magnetic energy stored in the inductor is given by so 4 microfarad and 2 ampere. So we know that energy is equal to okay, just a minute. So the here energy stored is actually half into L square. So this is indicate sorry this indicates that the energy stored in the inductor will be half or 1 by 2 mu 0 dl by li square. So I hope you remember this. So what is the energy? Energy actually this is the energy half L. I'm sorry, this mu will not come into the picture. So half L I square. This is the energy. So what is inductance? Self-inductance L is equal to 4 mu microfarad. So L we have got here. Oh, I'm sorry. This should not be microfarad. This should be micro Henry inductance. Half L I square. This is the current. So 2 whole square. So then, how much will be that? So this is 16 into 16, and this is sorry. So this will be 18 actually. 8 micro joule. So this, I think this will be C, option C, half L I square. That is the magnetic energy when the self-inductance of this inductor is given. Okay, then we can write half L I square. Half L I square we can write. Okay, so we'll move on to the next problem. If you have any doubt, just see this once again here. The energy stored in the inductor is purely magnetic energy, and that can be calculated as half L I square. Okay, half L I square. Now we'll go to the next problem. So this problem says let a wire be suspended from ceiling rigid support. Ceiling is rigid support like this, and stretched by a weight W attached at its free end. The longitudinal stress at any point of cross-sectional area A of the wire is. That means, see, this is kind of a wire. This is the wire W. At the end, it is free end, and this end is actually supported by this. This is ceiling set. Now, what will be the longitudinal stress? We generally know longitudinal stress means force per unit area. So that is the longitudinal stress. Longitudinal stress. So what is the F here? Force at each point on this wire is actually the weight of the block itself. So W by area. Area is a area of cross section. See, the longitudinal stress at any point of cross sectional area A of the wire. So cross-sectional area of the wire is A. So that's why it will be simply W by A. So this is the first option. Now let us go to the next problem. What is this problem saying? This problem is saying that an electric dipole is placed at an angle with an electric field of intensity this. That means electric field intensity is given 2 into 10 to the power 5 Newton per Coulomb, and see the theta angle is given. What is theta? I'll tell you. Theta is 60 degree. So the theta is like this. So if this is the electric field, then a dipole is kept like this at angle theta. A dipole is kept like this. So these are the dipole end. And see here, what is the question? Question: it experiences a torque of 4 Newton when it actually brings together. So this is the dipole. Suppose this is minus q, this is plus q, and this is the electric field. So the angle the dipole makes is the angle that dipole makes is theta with the electric field intensity. So that is what it is written here. So and the dipole experiences a torque. See, torque means how much? Torque is P cross E. P cross E. P is P is sine theta. E is given. Dipole moment is not given. This P can be even written as, let us say the dipole length of the dipole is 2L or L, or here it is given as 2 centimeters. So L is 2 centimeters. That is the length of the dipole. If the length of the dipole is given, then we can write P is equal to Q into D or Q into L. Let us write Q into L E sine theta. This is the thing. Now, what is this Q? We have to find out. Torque divided by L E, and this is sine theta. Theta is 30 degree. Torque is given as 4 Newton meter, and this L is 2 into 10 to the power minus 2 meter. Electric field is given 2 into 10 to the power 4, sorry, 10 to the power 5, and this sine theta is actually half. That means 2 can be written here. Okay. So this 2 goes, this 2 is this here. So here there will be plus 3, and here it will be 2 into 10 to the power minus 3 coulomb. That means it is 2 millicoulomb. So here it is, the answer is option 3. Now we'll go to the next problem. What is this problem saying? This problem says that in the hydrogen spectrum, the shortest wavelength in the Balmer series is lambda given. See, in any wavelength of this hydrogen spectrum, like we have how many spectrum? Lyman, okay, Lyman, Balmer, okay, Balmer, Pattern bracket and font series. So these are three, five uh, series we know. And the shortest wavelength when we are, first of all, in general, the wavelength can be found out by writing this in final, where it goes and from where it goes. Okay, so now in this case, see, when we say maximum wavelength, maximum, so Ni must be infinity. Okay, I'm sorry, this is not maximum, this is smallest wavelength or lambda max. Yes, that is also true, lambda max. Smallest wavelength in this case, and this is lambda max. Okay, so n has to be infinite. N has to be infinite. So Ni has to be infinite. Infinite means zero. Then you look this guy here, 1 over lambda. Let us write this as minimum here. So R into this term has gone. This is actually infinity. So this has gone to 0. So this is nf square. Okay. So if we write this as lambda minimum, okay, so this nf in this case, so we will be able to find out what is r. This is Rydberg constant. So this Rydberg constant can be found out from this information. So lambda mean is okay, so that is lambda. And what is nf? In the Balmer series, see, this nf is always 2, so it will be 4. So r is 4 lambda. Then see, we have to find out bracket series. So this is actually, see, nf will be 1 2 3 4. Nf will be 4. We'll put it this here itself. So 1 over lambda is equal to r into 1 by nf square minus 1 by ni square. Okay, in this we are writing for bracket series. Bracket series. So final will be 4th, and initial can be anything. So here for minimum wavelength, we have to take this ni as infinity. So r divided by r divided by nf. Nf is 4. Here it is actually 1 2 3 4. So this 16. Okay, now we have to find out what is r. So r is actually 4 lambda divided by 16 here. So this is lambda by 4 then. Oh no, I think there is some mistake. I'll just quickly do it here again. So this is Balmer r. This will be 1 over 4, as I said, because I had to do nf square minus ns square. So this, from here, what we get is, see, 4 by lambda will get as this. Now 1 over lambda bracket is equal to same r divided by, what was that, Lyman-Balmer pattern bracket. So this will be 16. Okay, so lambda bracket is equal to 16 by r. R is actually, r is how much? R is 4 by lambda b. Bracket is this. So 16 by r, and r has got, see lambda b is actually lambda that is given. So putting the value of r, so 16 by r by lambda, lambda goes to here, it will be 4 lambda. So it will be 4 lambda. Okay. Now we'll go to the next problem. What is this problem saying? This problem is saying that the ratio of fundamental harmonics produced by an open pipe. Let us draw this. So fundamental one is this, that here in the middle there will be node, and both at the end there will be antinode. Okay, like this. And here also it will be, I'm sorry, the fundamental one will be like this. Okay, and like this. So this is lambda by 4, this is lambda by 4. So total distance, total length of the, this must be lambda by 2, lambda by 4 plus lambda by 4. So this will be lambda by 2 will be the length of the organ pipe, right? So now we know speed. Here actually you have to harmonic. Okay, find out harmonic. So harmonic nu is equal to v by l. V by l. L is actually lambda by 2. Lambda by 2. So 2v by lambda. 2v by lambda is the fundamental I'm writing. Okay, or let us write 0. 0th of open. Okay, so now we have got one thing, another one for closed one side closed. There will be node anyway. And in this case actually so this is the open pipe situation is like this. Oh, I'm sorry. Open pipe situation will be this. Okay, so open pipe, look, in this case this is actually lambda by 4, this length of the wave. So lambda by 4 is equal to L here. That means lambda is equal to 4L by this is, sorry, this is V. 4L, that is the wavelength. So frequency will be V by V. Let us say that is V, not V0. Let us say that is V. So this will be actually 4v by lambda 0. Okay. Now if we take the ratio of these frequencies, this is actually fundamental frequency, fundamental frequency, frequency, fundamental frequency. Okay. So the fundamental frequency or fundamental harmonics of the open pipe, and this is for fundamental for closed pipe. For by lambda 0. So now we have got, see if we take this, we have to take the ratio. Let us take this ratio then. Lambda by 4. This is for open and this is for closed. So we have to take new open, new closed. 2v by lambda 0 and lambda 0 here by 4v. Okay, so we'll just strike them out. 1:2. So it will be actually 1:2. Okay, so uh, open by closed, open by closed. Yes, if it is closed by open, okay, I think there is something I'm just missing. So we know this open pipe. In case of open pipe, see there are two things you need to remember. Lambda by 4, lambda by 4. This will be, if you add them, this is the wavelength total wavelength lambda by 2, and this corresponds to the length L. That means L is equal to lambda is equal to 2L. Similarly, in case of one side closed, in this case it will be like this fundamental frequency. So this is actually lambda by 4, lambda for wavelength, and that is equal to actually length. Lambda is equal to 4L. Okay. So in this case, open case fundamental frequency, suppose FO, that is V is the speed of light in air, say V by 2L, and another case V by lambda is 4L. So this is, if we take the ratio of what we get, then so 4 will go up, right? FO is to OC, it will go here. Okay, you need to just check the calculation sometime. I may do something wrong in the calculation part. So it is actually, see, V by 12 V V by 12 for L by V again. This V, this V, this two. This is 2, and see in the denominator there is a 1. So 2 is to 1. 2 is to 1 will be the answer here. Okay, so I think I'll stop it here for today. We'll take up this the remaining questions in the next classes. So thank you for your presence. Bye for today.